Your phone uses a physics theory so strange that without it, GPS would be wrong by 10 kilometers every day. Right now, your phone is talking to satellites in space, moving at 14,000 kilometers per hour. They send time signals so precise that even an error of 1 microsecond can shift your location by 300 meters. But here is the shocking part. Time in space does not run the same as time on Earth. And if scientists ignored this, your maps, navigation, and even flights would completely fail. So how does your phone fix time itself every single second? You are walking in a new city late at night. Your phone suddenly says, "Turn left." You trust it and you follow the blue line on the screen. Somehow it always knows exactly where you are. But here is the strange part. Your phone is talking to space, not just the internet, not just mobile towers. It is connected to satellites obtaining far above Earth. Right now, more than 30 GPS satellites are circling the planet. They move at about 14,000 kilometers per hour, and they stay around 20,000 kilometers above us. And still, your phone can find your position within just a few meters. How is that possible? The idea is simple, but the accuracy is extreme. Each satellite carries an atomic clock. These clocks are so precise, they lose only about 1 second in millions of years. Every satellite constantly sends a radio signal toward Earth. Inside the signal is a timestamp, that exact moment it was sent. Your phone listens to signals from at least 4 satellites at the same time. It measures how long each signal takes to arrive. Because radio waves travel at the speed of light, about 300,000 kilometers per second, even tiny delays matter. If a signal arrives after 0.07 seconds, you are roughly 21,000 kilometers away from that satellite. Now, your phone repeats this calculation with multiple satellites at once. It creates invisible spheres around each satellite based on distance. Where those spheres meet, that point is your exact location. This method is called trilateration. It does not use angles, it uses distance only. But there is a serious problem. The system depends completely on perfect timing. If the timing is wrong by just 1 microsecond, which is 1 millionth of a second, your position can shift by about 300 meters. That means you could appear on the wrong street or even inside a building. So, scientists had to solve a deeper problem. Time itself is not as stable as we think. In fact, time can change depending on speed and gravity. And if this effect is ignored, GPS would start making errors almost immediately. Within minutes, your navigation would become useless. So every time you use maps, you are depending on a hidden correction, a correction based on the physics of the universe. This is where the story becomes truly mind-bending. Because the next piece of the puzzle comes from a theory that changed our understanding of reality. A theory that says time itself is flexible. And without it, your phone would be completely lost. So what exactly is this strange effect? And how does it control your daily navigation? In the next part, we uncover the truth behind time itself. And once you understand it, you will never look at your phone the same way again. Every route you follow will feel like a small miracle, powered by physics happening silently above your head right now in space today. We think time is simple. 1 second is 1 second, no matter where you are. But the universe does not work that way. Time can actually change. It can slow down, it can speed up. And this is not science fiction, this is real science proven many times. This idea comes from a scientist named Albert Einstein. Over 100 years ago, he introduced a theory called relativity, and it completely changed how we understand time. According to relativity, time depends on two things: speed and gravity. Let's start with speed. When something moves very fast, time for it slows down. This effect is called time dilation. For example, imagine a clock inside a fast moving spaceship. To someone watching from Earth, that clock would tick slower, even though inside the spaceship everything feels normal. This has been tested with airplanes and atomic clocks. Scientists flew clocks around the Earth and compared them to clocks on the ground. The moving clocks were slightly behind. That tiny difference proved Einstein was right. Now let's look at gravity. Gravity also affects time. The stronger the gravity, the slower time moves. So near a very heavy object, like a planet, time ticks slower. Farther away from gravity, time moves faster. This means time on Earth is actually slower than time in space. Now, think about GPS satellites. They are moving very fast and they are also far away from Earth's gravity. So, two things happen at once. Because of speed, their clock runs slower. But because of weaker gravity, their clocks run faster. These two effects do not cancel out completely. Instead, there is a small difference. And that difference is extremely important. Each GPS satellite's clock ends up running faster than clocks on Earth by about 38 microseconds every day. That may sound tiny, but remember, even 1 microsecond can cause a position error of 300 meters. So, 38 microseconds would mean errors of over 10 kilometers in just one day. Your GPS would become useless very quickly. You would see your location jump across the city. Navigation apps would fail completely. So, engineers had to fix this. They had to adjust satellite clocks using Einstein's equations. Before launch, the clocks are set to tick slightly slower. So once in orbit, they match time on Earth perfectly. Also, the system constantly corrects small errors in real time. This means every second your phone is relying on relativity. Not once, not sometimes, but all the time. Without it, GPS simply would not work. So the next time your phone shows your exact location, remember this. It is not just technology, it is physics in action. It is proof that time itself is flexible, and your phone depends on that strange truth every single day. But there is still one big question left. How does your phone combine all these signals so quickly and accurately? And what hidden math is running behind the scene? In the next part, we will dive deeper into the system inside your phone and uncover the final secret that makes GPS work perfectly. Now, you know something surprising. Your phone depends on time from space, and that time must be perfectly accurate. But here comes another question. How does your phone actually turn these signals into your exact location? The answer is a mix of simple ideas and powerful math. Your phone is always listening. At any moment, it is receiving signals from multiple GPS satellites. Each signal contains two important things. First, the exact time it was sent. Second, the position of the satellite in space. Your phone compares the time sent with the time received. The difference tells how long the signal traveled. Since signals move at the speed of the light, your phone can calculate distance. Distance equals speed multiplied by time. So now your phone knows how far it is from the satellite. But one distance is not enough. With one satellite, you could be anywhere on a huge sphere. So your phone listens to a second satellite. Now you have two spheres. Their intersection forms a circle. Still too many possible locations. Then comes a third satellite. Now the spheres intersect at 2 points. One point is usually far out in space. So your phone ignores that. You are left with one possible position. But there is still a small problem. Your phone's internal clock is not perfect. It is not an atomic clock like the satellites. So there is always a tiny timing error. That is why your phone needs a fourth satellite. The fourth signal helps correct the clock error. It adjusts the timing and gives you a precise location. This entire process happens in seconds. Actually, it happens many times every second. Your phone is constantly updating your position in real time, even while you are moving, but the system does not stop there. There are also small delays caused by Earth's atmosphere. Signals slow down slightly when passing through air, especially in the ionosphere and troposphere. So, GPS systems include models to correct these delays. There are also ground control stations. They monitor satellites and send updates. If a satellite drifts even slightly from its orbit, it gets corrected. All of this works together as one system: space, Earth, and your phone. A complete network built for precision. And the result is something we now take for granted. You open a map, you use a blue dot, and you trust it completely. But behind that simple dot is a complex system. It involves physics, math, engineering, and constant correction. Every step must be perfect. Every signal must be accurate. Because even a tiny mistake can grow very fast. Yet somehow it all works together smoothly. Your phone solves this invisible puzzle again and again without you ever noticing. But there is one final piece of this story, one thing that makes this technology even more amazing. Why was GPS created in the first place? And how did it become something we all use today? In the final part, we will uncover the origins of GPS and the surprising reason it exists at all. A story that begins not with smartphones, but with global strategy, science, and the need for absolute precision in a changing world. GPS feels like a normal part of life today. We use it for driving, walking, food delivery, and even tracking packages. But it was not created for everyday people. It started as a military project. During the Cold War, the United States needed a way to track submarines and missiles with extreme accuracy. In 1957, something important happened. The Soviet Union launched Sputnik, the first artificial satellite. Scientists in the United States noticed something strange. As Sputnik moved across the sky, its radio signal changed frequency. This was due to the Doppler effect. By studying this change, they realized something powerful. If you know where the satellite is, you can find your position on Earth. This idea became the foundation of GPS. Over the next decades, the system was developed and improved. By the 1970s, the first GPS satellites were launched. The system became fully operational in 1995. At first, GPS signals for civilians were internationally made less accurate. This was called selective availability. It was done for security reasons. But in the year 2000, this limitation was removed. Suddenly, GPS became much more precise for everyone, and that changed the world. Today, GPS supports billions of users. It is used in aviation, shipping, farming, emergency services, and smartphones. Even financial systems depend on it. Banks use GPS timings to synchronize transactions. Power grids use it to manage electricity flow. Without GPS, many systems would fail. And here is the most surprising part. Every time you use GPS, you are relying on relativity. The same theory once considered abstract and strange. Without correcting for time differences in space, GPS errors would grow by kilometers each day. So your phone quietly uses Einstein's ideas, not as theory, but as daily reality. It is one of the clearest examples of advanced physics in everyday life. Think about that for a moment. You are holding a device in your hand. It connects to satellites in space. It measures time with incredible precision. It applies corrections based on the nature of time itself. And it gives you your exact location, all in just a few seconds. What once required massive systems is now inside your pocket, and most people never notice it. They just follow the blue line, but behind that line is a hidden story, a story of science, discovery, and human curiosity. From Sputnik to smartphones, from theory to reality, from space to your hand. So the next time you open your map, remember this. You are not just using technology, you are using the physics of the universe, and it is working perfectly every single second.